This is the Chapter 7 review worksheet over area on volume, this method, and washer method. So let's look at number 1 here. The diagram shows the curve 4x minus x squared. That's the parabola that's opening down here. And the line y equals 3. That's this horizontal line. Calculate the coordinates of A and B. So we want to find the area, but first we need to find the bounds. So the way we can find those intersecting bounds, we can set the equation of the line equal to the curve. So 3 is equal to 4x minus x squared. We bring everything over to one side. We can factor this out. Multiplies to be 3, adds it to be negative 4. That's going to be negative 3 and negative 1. So we have 1 and 3. Those are our A and B values. So now we can plug into our area formula, which has our left and right bounds. And then we identify the top graph minus parentheses bottom graph. So the graph on top, in this shaded region, we see is the curve that's above. So that's the 4x minus x squared. That's the top function. Minus the bottom function, which is our y value of 3. So we're just simply plugging into our formula here, our top graph minus our bottom graph. All right. Clean that up. We can go through power rule like what I have shown here, or we can use our calculator using 36 Pro or the 84 Plus. Right, so either form is fine, just to be able to get to our area in terms of units squared. Number 2, now we're moving on to volume. So find the volume of the solid created by revolving this function bounded by the line y equals 3, rotated around this line. So if we can visually imagine what's happening here, this shaded region rotated 360 degrees around this line is going to create an egg-shaped object. And we see that this axis is up against, this dotted line is up against the flat surface of the shaded region, so there's no gap, there's no hole. We just have to go through this method. So this method says we draw the radius that extends from the axis to the shaded region, boundary of the shaded region. We do top minus bottom, 4 squared minus x squared minus parentheses 3. And that's our radius. So our formula for this method is pi big radius squared from our left bound to right bound. Our left bound and right bound still remains the same as 1 and 3. It's still the same shaded region, so a lot of information carries over. From 1 to 3, pi big radius squared. The rest goes in our calculator. Okay. And in our 36 Pro, you can simply use second E. That will take you to the definite integral notation and just plug everything in as you see it from 1 to 3, parentheses 4x minus x squared minus 3, quantity squared. And we leave the pi out of the calculator. This will produce 16 over 15, and then we just add that pi manually without using the calculator. Okay. All right, number 3. Find the volume bounded. So it's the same shaded region here, 4x minus x squared, line y equals 3. We have our intersections of 1 and 3. But now we're rotating around the line y equals negative 1. Now, what's going to happen is, if you can imagine this rotated all the way around this axis, there's this huge gap that we're going to have to make sure we subtract out. Otherwise, we're not creating what is the true volume of this ring-shaped object. So because of that, we have to draw 2 radius, one that extends from the axis of revolution, which I'm going to highlight in red here. And we're going to extend all the way from the axis to the boundary of our furthest shaded region, which is this curve. And then the next one is our little radius, which is going to extend from our axis to the other boundary here. Okay. Now we do top minus bottom for both. Top minus bottom for my top radius. The top is sitting on the 4x minus x squared. The bottom is sitting on the negative 1. So 4x minus x squared minus negative 1. That becomes 4x minus x squared plus 1. This represents the radius of the radius big R here. Little radius is top minus bottom, so 3 minus a negative 1. that becomes 4. So we say pi big radius squared minus little radius squared from 1 to 3. Use our calculator to plug in, leave the pi out of the calculator, and that is going to result in 176 over 15, and then we just put that pi in ourselves. All right, number 4, we have the same shaded region. Now our axis of revolution is sitting above, but we see that there's still a gap. It's not up against the flat surface of the shaded region, so we know that we still have to rely on Washer method, which requires us to draw 2 radius. One that extends from the axis to the furthest boundary of the shaded region, and then one that extends from the axis to the closer of the 2 boundaries. So your big R visually is always going to be longer in length than your little r. So big radius, we do top minus bottom. Top is sitting at the 6, the bottom is sitting at 3, so 6 minus 3 equals 3. For little radius, we do 6 minus the curve, so 6 minus, now it's important that we protect the bottom function with a set of parentheses, otherwise we're going to forget to distribute this negative through. So 6 minus 4x plus x squared cleans up to be, so this is as far as we can go. And then we plug into our volume formula for Washer method. Big radius, quantity squared, minus little radius, quantity squared. Again, bound from 1 to 3. Plug in the calculator without the pi, get it to a fractional value, and then we enter pi ourselves. 104 over 15 pi. All right, number 5, it's just asking for the area. So area, there's no rotation. We just simply do top minus bottom of our shaded region. So the top is sitting on the x squared. The bottom is sitting at the 2x squared minus 25. But we have to find the boundaries ourselves. So we're going to set the 2 equations equal to each other and see where they intersect. And when we solve for x, we're going to get x equals 5 and negative 5. Right? So top graph minus parentheses bottom graph. Important again that anytime you have multiple terms that is coming second, make sure that you leave it in a set of parentheses, otherwise we're going to forget to distribute the negative through. So we distribute the negative through, we combine like terms, we get it to a nice clean expression. Now we can use our calculator. Notice that there's no pi involved in our answer because there's no rotation, there's no circles involved. It's just simply top graph minus bottom graph, just the area calculation here.